Assalamualaikum warahmatullahi wabarakatuh. So in this video, I'm going to talk about another example related to hypothesis testing in one population, and the focus here is on testing the population proportion. In a poll conducted by the Ministry of Women, Family and Community Development, 51% of the women over 50 said that aging is not as bad as they had expected. Assume that this result holds true for the 2020 population of all women aged 50 and over. So the population here is just the women who aged 50 and over. Yep. And in a recent random sample of 400 women aged 50 and over, 54% said that aging is not as bad as they had expected. Using the 1% significance level, can you conclude that the current percentage, which is the percentage in a recent random sample given here, can you conclude that the current percentage of women aged 50 and over who think that aging is not as bad as they had expected is different from the previous poll, is different from the result given by this Ministry of Women, Family and Community Development here? Okay, so now first step is I'm going to just transform or change whatever words here into mathematical symbol. And if you look at the first statement here, the first statement here indicates the idea for the null hypothesis, because this statement says that we are going to assume the result given here is true for the 2020 population of all women aged 50 and over. And this one here, can you conclude that the current percentage, okay, percentage here is 51%, 54%, so we're talking about that. The current percentage of women aged 50 and over who think that aging is not as bad as they had expected is different from the previous poll. So this is different, just not equal. And so this statement clearly gives you an indication of what to write down as your alternative hypothesis. Okay. In a recent random sample, so this is the sample size, and 54% said that aging is not as bad as they had expected. So this is the p hat. So let's say we apply the traditional approach. We are going to start off with the hypothesis null and the alternative hypothesis. H null here is going to be P is the population proportion. This is equal to 0.51 based on the results given here, because it says here assumes the results here holds true. And then now here it says, can you see or can you conclude whether the current percentage is different from the previous poll? So this one gives you an indication that the alternative hypothesis is going to be P not equal to 0.51 different. Next is we're going to calculate the test statistic, and the test statistic is given by this one. Okay, so this is P hat minus P over, this is PQ over N. Okay. And the test statistic here is for testing the population proportion, and we know that when we use the Z statistic, we are going to refer to the standard normal distribution table later on for finding the critical value or finding the p-value. Now we're just going to substitute the numbers. P hat is 54%. This is the result from the sample, 0.54. Minus P is this one. P is equal to 0.51. So 0.51 can be substituted into this position, 0.51 over, so P is 0.51 times with Q. Q is just 1 minus P, and in this case it is going to be equal to 0.49 over the sample size is 400. So punch in the values into your calculator and you will see that the result here is going to be equal to 1.2. Okay, so this is the test statistic. Next, we are going to consider the critical regions and finding the critical values. So the critical regions here will be based on the standard normal distribution. Okay, so here is the middle point, 0.0, and we know that values to the right here are going to be all positive. Values to the left here are all negative. And since the alternative hypothesis is a two-sided hypothesis testing, it means it can go in either this direction or that direction, left and right. Therefore, the critical region are going to be on both ends. So this is the left side and the right side. Okay. Well, the critical regions here depend on the value of alpha. So alpha is 1%. Alpha is 1%, which is 0.01. And because you have two critical regions, you need to divide alpha with 2. So you will get 0.005 for each region. Okay, so the area here is going to be 0.005. This area also is 0.005, and you need to find what is this point here on the horizontal axis. What is the point here on the horizontal axis? Okay, so we need to find these 2 points here. There are 2 critical values. Okay, so let's say we refer to the standard normal distribution table. Let's say we use table 3a. In order to use table 3a, I need to know what is the area from this point Z to the left direction. Okay, so let's go back to our sketch here. The area here is 0.005. 0. This area is also 0.005. Now I need to find what is the value here. What is the value of this horizontal axis here and this one as well. So in order to use this table, I need to know what is the area from one point Z here to the left. Or in other words, I need to know what's the area from this point. This is the point that I want to know. I need to know what's the area from this to this. So I know that the area here is going to be equal to 1 minus 0.005, right? So this area is 0.005. So the green area which I need to find from this point to the left is going to be 1 minus 0.005, and this one is equal to 0.995. Okay. Now this area, or this is the probability value. Well, you need to find this area inside the table given here. And you can see that 0.995 is either, you can take either these two values here are equally close to 0.995. So either these two values are acceptable. Let's say you choose this value, 0.9949. Therefore, your Z is going to be 2.5 plus 0.07. So the value here is going to be 2.57. So this is the value here, 2.57. And the value on this side is also going to be the same, just that it has a negative sign. So negative 2.57. Okay, so those are the critical values. And I'm just going to write down that values here. So therefore the critical values is plus minus 2.57. This one is 2.57 for this one, and this one is negative 2.57. Now on the fourth step, we are going to decide whether we should reject or do not reject the null hypothesis. We're going to make a decision here, and the decision will be based on what you have obtained on the second step, and you will compare it with these critical values here. So based on the result of your second step here, we get the value is 1.2. We know that this is a positive value, and therefore we know 1.2 is going to be somewhere here. It's going to be between 0 and 2.57. Okay, because the value here gets bigger and bigger when it moves towards the right direction. So 1.2 is somewhere here, and you can see it clearly that the test statistic 1.72 doesn't fall into the critical region. So where is the critical region? The critical region is either this side, the purple area on this side, or this side. So test statistic 1.72, the test statistic 1.2 doesn't fall into the critical region. Therefore, H null cannot be rejected. H null cannot be rejected. As a conclusion, again, the conclusion is something that has to be related to the alternative statement given here. Since you cannot reject H null, therefore this statement is not supported, right? So that is another way of saying it. Unable to reject H null means this statement is not supported, and we can say that, we can say that there is not enough evidence to support this, to support that the current percentage of women, so this statement basically, to support that the current percentage of women aged 50 and over. So this is going to be a long statement, but basically I'm just writing down this part here. The current percentage of women aged 50 and over who think that aging is not as bad as they had expected is different from the previous poll. Okay, so basically at the end of the day, we have to answer the question of interest here. We cannot conclude that this is true. Okay, all right, that's all for now. Thank you very much.